In this example, we're going to look at where both the numerator and denominator of a rational function will equal 0 for a particular value of x. Okay, as a result of this, the function will be undefined at this x value. The function will be undefined at this x value. If this is the case, the graph of a function may have a hole. And a hole, a definition of a hole, is an omitted point in a graph. All right? So, if a rational function has the same factor x minus b in both the numerator and the denominator, then there is a hole in the graph at the point where x equals b, unless the line x equals b is a vertical asymptote. So we're going to look at a specific example and see how this plays out. We're given the function f of x is equal to x squared plus x minus 6 over x minus 2. All right? So what we're going to do is we're going to take this function now, and we're going to rewrite this with the numerator being factored out. If I'm looking at x squared plus x minus 6, I can rewrite that as a multiplication, and that multiplication is going to be x minus 2 x plus 3. So I'm kind of foiling this in reverse, okay? And again, my denominator is x minus 2. Well, I want you to note here that both the numerator and the denominator has an x minus 2, and I can factor that out. If I cancel that out, I'm left with f of x then being equal to x plus 3 over 1, or just x plus 3. And if you notice, we can put in a 1 there as a factor of x, and what we have is a linear equation. So I have f of x equals 1x plus 3. This 3 is my y-intercept, and the 1 is my slope. So if I were to graph this, here's an xy coordinate plane. If I were to graph this, I'd have a y-intercept at 3, so I would cross the y-axis at 3. Okay? And I have a slope of 1. So from this y-intercept, I would go up 1 to the right 1, and then I would go ahead and draw a line. So we basically have a linear function. Now, this right here, the whole, here I have where x minus b, x minus 2 in this case, in both the numerator and the denominator. So x minus 2 equals 0. If I add 2 to both sides, now I go x equals 2. So at 2, then 1, when x is 2, so I take now and go up to the equation. By the way, where would that be? What would the value of y or f of x be if x was 2? Well, I'm hoping you plug 2 in here, and you see, oh gee, 1 times 2 is 2, and 2 plus 3 is 5. So when y is 5 and x is 2, there is a hole in that graph. There is a hole in that graph. If I were to actually graph this on a graphing calculator, you would see it would be discontinuous at this one point. Okay? There would be a hole there. So that's the hole of that particular graph.